Hello, everybody, and welcome to today's webinar presentation titled The Data Bimodal, brought to you by Enov8. Let's meet our presenters today. First, Neil Crawford. Neil, based in Brisbane, Australia, is the CIO and founder of Enov8. A software engineer at heart, Neil started writing code back in the 80s when 1K of memory was still enough. He has worked across many industries like government, telecom, airline, and finance. Prior to starting Enov8, Neil was the executive manager at the Commonwealth Bank of Australia. During his time at CBA, Neil noticed obvious gaps in the market, particularly in the areas of test environment and test data management. Ultimately, it was these observations that led to Enov8, the environments and data company, being formed. Second, let's introduce Ash Hosking. Ash, based in Sydney, Australia, is the technical director of Enov8. Ash has worked for Enov8 for 8 years and has worked in the software delivery, environment, and data management space for over 12. Ash's experience crosses a wide range of sectors, including telco, banking, and government. Outside of work, Ash is a passionate motorcyclist and a volunteer firefighter. At this time, I'd like to pass it off to Neil for the beginning of the presentation.
Cool. Thank you, Drew. And hello all. As introduced by Drew, I'm Neil, and I'm one of the co-founders of Enov8. And today I'm going to be chatting to you about the Data Bimodal. However, before I do that, perhaps I'll start with a little bit of context about who are Enov8, where do we come from. Okay, so a little bit about Enov8. We're headquartered in Sydney, Australia, and we've been going for about 9 years or so. Our mission is basically to help organizations better understand and manage their environments and data. We currently have 3 core solutions. That is our IT and test environment management platform, which is all about helping organizations model their IT environments and systems, plan and coordinate activities, streamline and automate operations, and centralize status accounting and reporting. We also have an enterprise release management platform focused on helping you manage your delivery activities across the enterprise release spectrum, which is a fairly broad spectrum, including implementation planning, deployment automation, version tracking, and cross-project release train collaboration. And last but not least, we have our data compliance suite, also known as DCS, which is probably a little bit more relevant to today's conversation. But in a nutshell, DCS is a RegTech or DevSecOps tool, helping organizations ensure data and privacy compliance, and also streamline data operations. Regarding our reference architecture, as I already said, we have the 3 core platforms, and these are built using our low-code framework called Ecosystem. Ecosystem is our own proprietary, object-oriented, rapid application development engine, allowing us to build new products or capabilities quickly. And it also includes a code-agnostic DevOps manager, basically an automation layer, an area to add your automation scripts, agents, playbooks, and schedules. Today I want to talk about the bimodal. So first of all, what is the bimodal? Well, if you're in IT, you've probably heard the term bandied around by the likes of Gartner. But simply put, Gartner describes it as the practice of managing 2 separate but coherent styles of work. Mode 1 is focused on being more predictable, risk adverse, standardized, and rigorous. Think waterfall and legacy. And mode 2 is more focused on experimentation, being exploratory, solving new puzzles, and just being less risk adverse. Think agile and building new minimal viable product. However, obviously Gartner don't own the term. the term bimodal has been around a lot longer. And in fact, bimodal means having or involving two modes or distributions, or having 2 points of focus or attention. And with that in mind, today's focus is the data bimodal. That is looking at the needs of data from the perspective of 1, delivery, and 2, security. 2 modes with very different intents, obviously. And I guess 2 modes that don't necessarily or don't naturally mix that well. So let's have a look at these in slightly more detail. Starting with mode 1, delivery. The basic premise is I want to get these changes completed and out of the door as quickly as possible. Therefore, I'm looking for minimal fuss, minimal overheads, and it's probably fair to say I need just enough. There's no real need to make this complicated. In other words, my core need is agility, and with that in mind, I'd be looking for small data footprints, more focused on the task at hand. That is the actual slice of new functionality. I'd want to build and deploy quickly, minutes, not hours. I'd want the process to be easily repeatable, allowing ease of rollback, retest, etc. And I'd want the data to be easily consumed. That is, I should be able to find or use data with minimal operational overheads. From a positioning perspective, mode 1 is very much developer-centric. It's about enabling teams or tribes. It's more laser-focused. That is addressing the needs of a microservice or story. And it naturally gravitates or lends itself to lower-level test environments like development, unit, and system test. Basically environments where the people or teams can get the job done with minimal fuss and minimal collaboration. And from an execution perspective, the methods should be frictionless. That is, you would look to employ data fabrication, small and consistent sets of fake data that focus on the features or stories. You'd look to replace common and recurring data operations, including data admin tasks, with code. You'd look to leverage the benefits of immutable objects. People should be able to quickly deploy and redeploy their images. So think SQL import files and containers held in your release repo. And you'd want to establish methods that make the data easy to find and share. Okay, so what might this look like from the perspective of a DevOps pipeline? Well, we have the standard DevOps pipeline shown in white, classically moving from version control, build, package, deploy, and eventually promotion through the test environments. And underneath, running in parallel, we would have a set of corresponding data mode 1 methods. That is, we would prepare and house our fabricated data sets under version control, and we would employ DevOps-like routines that pull out key database artifacts like schemas, stored procs, and the fake data, and then build and deploy. I'd see these methods heavily embedded inside your existing CI/CD routines. And as indicated previously and sitting at the top, I would suggest you codify and expose recurring data or data admin operations. And if the data is complex, I'd suggest some simple data mining routines to quickly find fit-for-purpose data. Okay, so what challenges does mode 1 encounter? Well, I guess despite my somewhat simplistic overview, data and its underlying structure is rarely simple, and at times it can be incredibly complex. It's not uncommon for databases to consist of hundreds or thousands of tables, each with 10, sometimes even hundreds of columns. And the relationships between these columns and tables is often non-trivial, and it can be managed both inside and outside the databases themselves. Secondly, data inside production is often very hard to mimic. In a brand new application, this is probably not a concern. Some applications could be 5, 10, or 20 years old, and the data that's formed was derived by an ever-changing front end and changing business and integration logic. It wouldn't be difficult to create data that, despite good intent, doesn't meet the mark. A little like the famous restoration of this fresco. The intent was good, but it certainly didn't meet the mark. And last but not least, although creating simple data structures may seem preferable, you do need to consider the consequence. If it doesn't look or behave realistically, then don't assume testing will be realistic. And if testing isn't successful, then your data issues and exposures will move right. I mean, ultimately exposing yourself to poor quality, unhappy customers, and potentially security vulnerabilities. Okay, so now moving on to the other side of the spectrum, data mode 2. In this mode, I require my data to focus on regulatory/security policy. That is, I need to conform to the relevant regulations, for example, privacy regulations like GDPR, HIPAA, PCI, etc. I need to understand and identify where my risks reside. Where are my customers' sensitive details? I need to ensure the risks are protected. I ultimately need to demonstrate compliance to interested internal and potentially external parties. And of course, I need the data to look and feel like production so it can be properly exercised. From a mode positioning perspective, I'm concentrating on the customer and product acceptance. I'm aligning myself to compliance teams like security and audit. I typically would be focusing on the big picture, the complete product and its interactions, not just a thin slice. And I guess I'm ultimately moving my focus right and focused on production readiness and protecting my end users. And from an execution methods perspective, I think the key word here would be protective. I'd be looking to implement methods to automate risk discovery and data literacy. I'd be looking to implement methods and consistent methods of that to mask or encrypt the data. I suggest we have automated validation or test routines to check that the end data is indeed secure. I guess simply put, we don't want PII, personally identifiable information, slipping through the net because you forgot to mask one column or one table. And boringly to some, we need to collect and ultimately produce evidence. That is, I'd want to be able to generate logs, coverage reports, and provide proof of compliance. Okay, from a pipeline perspective, it might look a bit like this. Again, I have the standard DevOps pipeline shown in white. However, underneath and not necessarily in parallel, as these tasks are less atomic, we have the security pipeline boxed in green. This security pipeline is essentially an ETL process. That is, we would extract or clone from production to ensure production likeness. We would have profiling routines to understand the data and find the risks, identify the PII. We would have a set of consistent automated methods to transform, mask, encrypt, and validate the sensitive data. Note, consistency is very important here, as we want to ensure integrity of data within and across the applications. And finally, we would store the reusable and secure artifacts, which are often called gold copies, in a repo ready for load and reload. And underpinning all this, I'd also ensure logging and reporting to ensure we can respond to future audit or security requests. Of note, you may have spotted a red box on the bottom right. Simply put, using production data is rarely reasonable and rarely excusable. However, if it is something you require, then you would also need to set up an exemption pipeline. Basically, that will allow production data to be cloned and deployed if and only if the necessary security workflow has been followed. So as a minimum, workflow should capture the risk, communicate the risk, ledger the request, and record any associated executive decision making. I say executive is the risk of using customer security. The risk of using customer data should never be made lightly. Okay, so I think I've distilled the key concepts of mode 2. What challenges face this mode? Well, like mode 1 challenges, data is complex. Think thousands of tables, tens of thousands of columns, and potentially millions or billions of data points. 2, risks are often well hidden. Don't rely on naming conventions of the tables and columns, as they often mislead. And don't forget the use of hidden temporary tables. 3, regulations are evolving. That is, the risk today may not be the same as the risk tomorrow. Change is constant. 4, preparation of useful, that is secure prod-like data, can be very time consuming. It is not uncommon to spend months trying to decipher and automate medium complexity systems. And finally, shortcuts are tempting. There is often pressure, often from the most senior stakeholders, to get the changes done as quickly as possible. However, I guess on that point, be warned, there's no one really with the authority nor senior enough to put your customer data at risk. And of course, that's why you needed the exemption process as outlined in the last slide. The way I kind of see it is if it does go wrong, then at least everyone should know who's accountable for making that decision. Okay, so which mode do we use? Well, if you're an organization with no sensitive data, then feel free to use mode 1. Open the throttle, go 100 miles an hour. If you're an organization with lots of sensitive data, like medical or financial, then I'd be leaning towards mode 2, lift the drawbridge, control what goes in and out. However, if you're like 95% of organizations, then the correct answer is to obviously blend them both. So therefore the question isn't really which, the question is probably when. Okay, so here's my representation of a data factory with a blended data bimodal implementation. First thing to call out, I guess, is there's no hard or fast rules. Data methods will inevitably bleed between the two modes. However, simply put, in blue, mode 1, I have a focus on speed, lower environments, and early lifecycle activity. I'd be looking to use fake data, and I'd integrate my database build and deploy into my CI/CD automation. With respect to logging and reporting, I keep it very light. Perhaps I'm focused on DevOps metrics to promote continuous improvement and fluidity. In red, mode 2, I'd have a focus on security, higher environments, and later lifecycle activity. In summation, I'd promote secure and large production-like data. Deployment is a lot more periodic. It's in alignment with the later acceptance cycles. Reporting-wise, reporting is very much necessary. There should be a focus on satisfying your compliance, that is your security and audit stakeholders. And finally, in green, we have the components that probably best live on both sides of the fence. I'd be looking to implement shared methods for data literacy, data profiling. All team members should understand the data they're working with. I'd be implementing shared methods for data consumption. All team members should be able to find data quickly and without contention. And I'd look to codify and make self-serviceable popular and repeating DBA or database operations. Obviously, by making them self-serviceable, I'd avoid the common bottlenecks often associated in accessing the database admins or experts. Okay, so that's enough of me talking about the differences and goals of the bimodal and how I would set up a data factory. What I'd now like to do is pass the baton to my colleague Ash to talk about how one might achieve these goals using our Enov8 platform. As mentioned at the start, we have a solution called Enov8 DCS, Data Compliance Suite, which has been designed specifically to focus on data security and data operations. So with that in mind, I'd like Ash to show you some of the features that I discussed today. So Ash, over to you.
Thanks, Neil. I'll just share my screen. Okay. So the first aspect of the solution is when you log into it, you're greeted with a landing page, which shows you some high-level analytical information and can also be branded to your organization. Now, what I'm going to do is I'm going to take you through some of the aspects of the solution from a Mode 2 data security perspective, and then we'll circle back and explore some of the functionality from a Mode 1 data ops perspective. One of the first aspects of the solution is obviously connecting it to a data source. So one of your say relational or non-relational or API-driven data sources. So this could be, for example, an Oracle database or a NoSQL database such as a MongoDB, or it could even be a flat file such as a fixed width CSV or XML-based data source. Connecting to that via an ODBC connection. Once that is connected, basically the next aspect of it from a data security perspective is to basically create a configuration file from a profiling perspective. So the actual data security aspects of the solution follows a very simple process of profile, mask, and validate. And the first step is profiling that data. So first of all, we need to basically identify what kind of data is actually sensitive, what is personally identifiable information. And commonly, a very simple and straightforward approach is to identify actual primary and secondary PII. So an example of primary PII would be things like full names, first names, surnames, and organizational names. We may also want to address email addresses as part of that, because commonly a person or an organization's email address will identify their name. And then we also have some other sensitive information that we're looking at, such as addresses, date of birth, credit cards, which although don't identify a person just by having that information, it's still very personal information. So we're still wanting to address it in this particular example. You may also have some other identifiers that you want to basically address, and that might be things like company identifiers, tax file numbers, social security identifiers, etc. So once we've got our configuration file basically configured, and the Enov8 DCS suite, data compliance suite, comes with a suite of various different configurations out of the box for various different geographies. They can basically be tweaked to an organization's requirements, and we can set that up. So once we've got that, we can basically execute that against our data source. So I've got a number of data sources that I've got connected here. I'm going to use my Oracle one in this particular example, and we can basically execute that against this Oracle database. And then what it's going to basically be doing is it's going to be looking for any information within any of those columns within the database, which may reside within a particular table, within a particular schema within the database. And it's basically scanning to identify any information that matches any of those patterns that we've set in our configuration file. One other thing that the solution also does is it looks to see if there's any column naming conventions from a metadata perspective that would also suggest that the table or column contains sensitive information. So what that basically does is it allows us the ability to identify, if I jump into this report that's just finished from my scan, is to identify if any of these column names have identified potentially where there may be some sensitive information residing. In addition to, from a meta perspective, the more important aspect is also looking at data content. So here we can see anything that's actually been marked as primary data, primary PII or personally identifiable information. And we can have a look at an example of any matching data in here. And we can also see how many rows that it's counted in that particular column as well. Based on the profiling, what the tool then does is it automatically creates a masking configuration file. And within that masking configuration file, it's basically deriving from a mixture of default suggested masking routines or a bit of machine learning and artificial intelligence from utilizing the tool over time is it's basically identifying what the suggested means of remediating that security risk within the data. So we can see in this example, it's identified all of the various different sensitive information fields. And then if, for example, I wanted to change one of these, let's say I wanted to override it, I can basically edit any of those and I can change that. I can change how I'm going to mask it. So if, for example, I wanted to mask the whole column as a fixed value instead of a many-to-one replacement from a lookup file, I can basically change that accordingly. The next aspect of the process, once I'm happy and I've rubber stamped my masking configuration file, which may be done in conjunction with, say, the application owner or the application team that manages that particular application, is to basically execute that similarly to how we have done with the profiling. So it's a very similar sort of straightforward, streamlined approach. And once that's basically been masked, then the process is that we can basically identify if there are any sort of deviations that we may need to do with that masking routine. For example, let's say we picked a masking function that was going to do non-unique values into a column that requires unique constraints. We may need to tweak that and run that again just for that particular column. But we can see in this example that we ran just before here, that took about 6 minutes, that masking completed successfully. So the process then is, once it's basically been masked, is to then basically validate if any production data resides in the database post masking. So what we can do is we can run a validation on the actual original data set, and we can see that there's a very high likelihood of production data residing in the unmasked data set. It was 80% and 72% for these two name fields, so that's identified that production patterns have been found. But running that post the mask, we can see that that production likelihood has dropped down and it's now below our production pattern threshold. Now, the way that that works is basically if I jump into another area of the solution for validating pattern management, we can basically execute a pattern search on a particular data set. So commonly what you would do is you would run this against your production data sets, but prior to masking, and you would basically set this as a benchmark for your unmasked data set so that the validation is very accurate as it's been aligned to your own data set. So if I have a look at this particular action that we've done on, say, our last name or surname fields, we can see that the most common surname in this particular column is Smith. So the process that we can do is we can basically take this quick scan that it's done against this production data set, and we can save that out as a pattern that can then be utilized in the future for validating if our masked data contains any sensitive information. So that basically allows us the ability to use pattern matching, which is very unique to the Enov8 DCS product, to basically identify if any sensitive information still resides post-masking. Now, one of the other aspects of the solution, to sort of start to go back towards the other side of the fence, which is the mode 1 data ops aspect, is to then also look for ways of identifying where fit for purpose data for the developers and testers actually is available within our application, because there's one thing to mask the data, but another aspect that commonly organizations struggle a little bit with is actually identifying and mining test data post the masking process. So what we can do is we can basically create different windows to our test data, which are basically just selection statements that could be querying our relational SQL databases, our NoSQL, or our various other sources that we can tie into. And then we can basically make those views public to the various different developers and testers. And the process then is basically we can go into our view windows area and we can execute that. So that then allows us the ability to run this against our sanitized data set that's been masked and cleansed of any production patterns. And we basically get a nice production-like data set that we can then utilize. So what the developers and testers can then do is basically use this to identify data that matches their particular use case. So I may want, say, a user that's an individual. For my particular use case, I may need a female customer, and then I can basically add more and more different requirements on the particular test accounts that I'm mining for. We can then export that out to Excel or a CSV file, and then you can either utilize that for your manual or your automated testing, whether that be performance or various other different automated test cases. One of the other aspects of the solution is obviously reporting. So from a compliance perspective or data security perspective, there's various different dashboards and reports which allow you the ability to identify where your different data sources have been basically processed by the solution from a profile mask and validation perspective, so you can identify what is actually compliant and what needs attention. And we can also dive into more detail, so we can actually see other aspects of reports. Here's just another example where we can identify from our data sources what the most commonly or common data types from a sensitivity perspective are within these solutions. So we can actually identify which databases have the most sort of sensitive names, email addresses, or other types of sensitive information. Now, just to continue on from a data ops perspective, is one other aspect that Neil was mentioning was from a data generation or fabrication aspect. The solution also allows the ability to fabricate or generate data which may not exist in your production environments. So it may be, say, a new particular product or something else that's being introduced into the organization or a particular system, and you may need to generate data for that particular use case that you're wanting to develop or test against. So the solution allows you the ability to basically generate data. You can basically create that either with whether it be a SQL or CSV or a JSON file, and basically generate how many different rows or batch sizes you want as part of that. Now, once that's basically been created, that's where the DevOps or Data Ops library comes into the piece. So whether it be a script that's basically been created as part of the solution, or whether it be calling an external script that's been created as part of your whole end-to-end life cycle, you can basically add scripts to the Data Ops library. And it's basically a simple process of drag and drop the scripts, select your script language. We support virtually any language, whether that be a Python or a PHP or a shell or SQL file, or virtually any language can basically be managed and orchestrated as part of the solution, whether that be a script language or an external tool. And we can also set ownership on that particular script, so who has ownership and can change it, and who can execute it, who has run permissions on that. And then the process past that is we can basically execute these straight from here if we wanted to. And we can also explore our scripts as well. So just before we created our fabrication script, we were going through the process of data generation within the fabrication area. And here we can see an example of that. So it's basically a very simple SQL file that's been created by the solution. And we can see some examples of the data that's going to be inserting as part of that fabrication process as well. And to note, the solution does cater for multilingual as well. So we can do any language as part of the solution. From a reporting perspective, for Data Ops, we can have a look at some of the different dashboards. So in this example here, we can see the Data Ops footprint by system, so how many different scripts we have per our different application databases across our organization. And we can also see the Data Ops distribution by type as well, so which script types are commonly used the most within the DCS solution. We can also see some trend information as well from our Data Ops masking, how long the executions are taking and the average lead time for those. And we can also see the execution distribution by a monthly aspect as well. So we can see what types of scripts are actually being run on a per monthly basis, so that we can identify what the most commonly utilized types from an operations perspective are. These are all just examples of the reporting that's within the solution. Various different custom dashboards, or as we call them, information walls, can be created via the various different data bricks within the solution, and that's all something that the client-side administrator and users can actually create these various different information walls so that you can tailor insights to your specific requirements as well. So that's natively generated within the solution, so it allows a very easy means of creating minis from the front end as well. So that's all I wanted to cover off today in today's quick demonstration. I might hand it back over to DZone now.
Perfect. And with that, DZone would like to thank both Neil and Ash for a great presentation. DZone would also like to thank Enov8 for providing the audience with a great webinar. Lastly, thank you to everyone who watched our webinar today. We hope you learned something new that will help you in your developer career. Have a great day.